second video on quadratics, and it involves solving equations, and most of the time we're going to be looking at completing the square, but we're also going to look by factorization. There are actually three ways that you can solve quadratic equations. We can do completing the square, we can do it by using the formula, which we'll look at in the next video, and you can also do it by factorization. Now usually if you're not told a particular way to do it, then we'd usually use factorization if we can, because that's going to be the quickest. Now if I'm going to factorize an expression like x squared minus 5x plus 6, I look at the start and I say, well, to get x squared I've got to do x times x, so there's got to be an x at the front of each bracket. Then the next place I look is the plus 6, and I say, well, what numbers multiply to 6? It could be 2 times 3 or 1 times 6. So either of these combinations would give us 6 at the end. But I also want to get minus 5x. Well, actually, for this one, I can get 5 either way. I can have 2 plus 3 coming to 5, or I can have 6 minus 1 coming to 5. So at the first glance, either combination would work. So let's say we tried for 1 and the 6 in there first. Well, to get plus 6, the signs must be the same. But if they're both the same and I want minus 5x, they've got to both be minuses. So if I had minus 1 there and minus 6 here, well, minus 1 times the minus 6 does come to plus 6. If I got minus 1 and minus 6, I will get minus 6 times x minus 6x, minus 1 times x minus x. So that's minus 6x minus another x is minus 7x. So it's not actually working. So the thing is that you're looking at here is that if you want a plus 6, it means the signs must be the same. So instead of having two things which subtract to give us the 5, I want two things that add, two numbers that add to give us a 5. So what I want is I want the 2 and the 3. So again, I want to multiply to plus 6, so the signs must be the same. I want to get minus 5x, so they must both be minuses. Let's check by expansion. X times x, x squared. X times minus 3, minus 3x. X minus 2 times x, minus 2x. So minus 3x and minus 2x is minus 5x. And finally, minus 2 times minus 3 plus 6. So that's worked. Now, that means that here, what we're looking at is you've got x minus 2 times x minus 3 is 0. Well, if two numbers multiply to 0, one of them must be 0. Now, x minus 2 is a number. Whatever x is, x minus 2 is a number. So x minus 2 is 0, or x minus 3 is 0. And that means that x is 2 or it's 3. Now let's look at this one. X squared minus 5x minus 6 equals 0. Now this looks very similar, x times x, x squared, but notice the signs are going to be different. To get minus 6, the signs must be different. One will be plus, one will be minus. Now I've got to decide here, and I can still use the 2 or the 3 or the 1 and the 6, but because I want them to be different and to come to minus 5x, I want two numbers that subtract to the 5x to give me 5. So I want 6 minus 1. Okay, so when I wanted a plus 6, I wanted two numbers that multiplied to 6 and added to the 5. Here I want two numbers to give minus 6 but multiply to the 6 but are going to subtract to come to the 5. And so what we're going to get here is I want to get it multiplying to minus 6, so the signs are different, and I want minus 5x, so I need to be subtracting more than I'm adding. So I want to subtract the 6x and add the x. So I've actually got those the wrong way round. I want them like that, because I want x squared plus an x minus a 6x to come to minus 5x, and minus 6 times plus 1 is equal to minus 6. Now if I've got it that way round, then I can say either x minus 6 is 0, so x is 6, or x plus 1 is 0, so x is minus 1. So you've got to be quite careful when we're drawing these and choosing the numbers. Now, let's look at a harder one. These were just x squared. Notice here I've got a 3x squared. The first thing to look for here is, say, is there a common factor? Well, 3, 6 and 3. 3 is a common factor. So I can remove the 3 as a common factor. What's left inside the brackets? Well, divide everything by 3. X squared minus 2x plus 1. So we get 3 lots of x squared minus 2x plus 1 is 0. Now it becomes straightforward, because what you're doing is you are saying, what is it but x squared minus 2x plus 1 factorizes to? Well, it's got to be x and x at the start. It's got to multiply to 1s, and the signs must be the same, and so it's going to be an x minus 1 times another x minus 1. Okay, x squared minus x minus another x, that's minus 2x, minus 1 times minus 1 is plus 1. And the reason I know they're both minuses is the signs are the same to get plus 1. We've got both the minuses to get a minus 2x. Now, so, here, to solve it, well, we've got 3 things now multiplying to 0. 3 is never 0, so that isn't. So x minus 1 is 0, or x minus 1 is 0. Well, it doesn't matter which I choose, gives me x equals 1. So this one has only got one solution, x equals 1. Now, let's look at this one here. This is a bit harder. Notice that you've not got a common factor. This had a common factor. 3 went into each part. This one doesn't. So what we have to do is we'd say, well, to get 3x squared, I'm going to have 3x times x. Now, we now need to be really careful. We could have 2, 5, 1 and 10 to multiply to 10. So 2 times 5, or 1 times 10. It's a minus 10. So that means that the signs are going to be different. So we're looking at subtracting the numbers to be left with a single x. But it doesn't seem to work, because 5 minus 2 doesn't come to 1. 10 minus 1 doesn't come to 1. So at first glance, it doesn't seem to be working. What we've got to realize is that this number will be multiplied by 3x, and this number will be multiplied by the x. So it makes a difference which way round we put the numbers in. Okay, so our 10 is 1 times 10, or 2 times 5, so we can put the numbers in. So if, for instance, I put the 2 there and I put the 5 here, that would give me 3x squared from here. Then all I do is I look at the number of x's, because I know the 2 times the 5 can give me the 10. 3x times 5, 30 is 15x. 2 times x is 2x. Well, there's no way that 15x and 2x can come to a single x, so that can't work. But because these are different, 3x and x, I've got to try this the other way around as well. 6x, 5x, well, that is going to work. So that looks as if that's working. But let's just try the others first, just to see if they work, if these would work as well. 30x and x can't come to a single x, so that cannot work. And then this way round would be 3x, 10x, 3x and 10x can't come to a single x either. So the only way this can work is to have a 5 here and the 2 here. And that means you're going to get 6x and 5x coming to an x. The signs are different, so that means that you're going to get minus 10 from different sides. I want to end up with plus x, so I want to add more than I take away. I need to be careful though, because when I'm looking at what I'm adding, what I'm taking away, I'm not looking at 5 and the 2, I'm looking at the total of the x's. That is 6x, that is 5x. So I want to add the 6x and take away the 5x. Let's now try expanding it. 6x squared, sorry, 3x squared plus 6x minus 5x is plus an x, minus 5 times plus 2 minus 10 is 0. So we get two things could be 0. Either 3x minus 5 is 0, which will mean 3x is 5, or x plus 2 is 0, which means x equals minus 2. Now, if 3x is 5, x is 5 divided by 3, and I'd leave it as a top-heavy fraction, 5 over 3, or the x is minus 2. completing the square. Right, here's our second method, and we're going to look at completing the square. We're going to complete the square for this, and then use it to solve x squared minus 8x plus 7 is 0. Right, a key thing here for completing the square is we look at the x minus a all squared and think, well, x minus a all squared, what does it come to when you expand it? So if I'm putting this x squared minus 8x plus 7 into this form, I say, well, what happens if I expand the x minus a squared? I get x minus a times itself is x squared minus ax minus another ax, so that's minus 2ax, minus a times minus a plus a squared. So do you see that you're getting x squared minus 2ax plus a squared? This is another useful result to remember, that x minus a all squared is x squared minus 2ax plus a squared. Now if I compare that with this, then what I see is x squared's there. Let's look at this bit here. I want minus 2a to be the same as minus 8. So what I'll do is I'll divide that minus 8 by 2 in order to find a, because minus 2a's got to be the same as minus 8. So if I divide by 2, I'm going to get the a as 4. So what I look at is x minus 4 all squared. So I go to this expression here and I divide that 8 by 2 and I keep that sign there the same. So I'm looking at using x minus 4 squared. Now, you can learn a rule for how we work this next bit out, and the rule works in the easiest cases quite easily. But I prefer to go through it and see why we get the rule. So, let's look at x minus 4 all squared. Let's expand it. You get x squared minus 2 lots of 4 times x, in other words minus 8x, plus 4 squared, 16. So you get x squared minus 8x plus 16 when you expand that. If you compare this to what we started with, you'll see that the difference is we've got a plus 16 instead of a plus 7. Well, we can rearrange this expression, and you can say that x squared minus 8x is equal to the x minus 4 squared. I'm moving the plus 16 across, so I take away the 16. So this is the key bit. You get x squared minus 8x is x minus 4 squared minus 16. So x squared minus 8x plus 7 is 7 more than that. So it's going to be x minus 4 squared minus 16 plus 7. Minus 16 plus 7 is minus 9. So when we complete the square, we get x minus 4 squared minus 9. Okay, now a lot of people just remember it as divide that by 2 to get your x minus 4, the minus 4 there, x minus 4 squared, and then you take away the 4 squared, take away the 16, and the easy cases that will always apply. Now, we want to solve now x squared minus 8x plus 7 is 0. Well, if we've completed the square, we would use that to solve it. And anyway, it says hence solve, which means I must, and whenever it says hence solve, you've got to use your previous result. So, if x squared minus 8x plus 7 is 0, x minus 4 all squared minus 9 must be 0. We need to solve this. Well, let's move the 9 to the other side. You get x minus 4 all squared is 9. Square root both sides. Be careful. Square rooting here, we get x minus 4. But when we square root 9, you've got two answers. You've got plus 3 or minus 3. You're square rooting the 9. You get plus or minus the square root of 9. So you get plus or minus 3. So you're getting your two answers. So the values of x are, x is going to equal either 4 plus the 3, the minus 4 when it moves across becomes plus 4, so you get 4 plus 3, 7, or it becomes 4 minus the 3, 1. So you get 3 plus 4, 7, minus 3 plus 4 is 1. I just move the minus 4 across, made it plus 4, and I'm getting my two answers. Okay, now that's the straightforward type. What happens, though, if instead we've got something like this? Instead of having an x squared, notice I've got 3 lots of the x squared. So now I'll have a number outside here. It's quite easy to spot what the number will be, because that's coming to x squared when I expand it. K lots of x squared is 3x squared, so the k is going to be 3. So that's easy to spot, but the k there will be the but the rest of it is going to be a little bit tricky. If x plus a squared, notice that on the previous one I said x minus a all squared became x squared minus 2ax plus a squared. X plus a all squared, when you expand it, becomes x squared plus 2ax plus a squared, because you get x squared plus 2 lots of ax plus a squared, because it's x plus a times itself. Now, if we have a look at this, we want not x plus a all squared, I want 3 times it. And that will become 3x squared, which is what I want. But notice now, I'll have 6ax plus 3a squared. So when I multiply through by that 3, I've no longer got 2ax, I've got 6ax. So my 30 equals 6a. So I don't divide by 2 anymore, I divide by 6. The easy way to remember it is you always divide by 2, but if I've also got a number here, like this case 3, I've got to divide by that as well. So I divide it by 2 and I divide it by 3, so I'm divided by 6. So what I'm looking for now is, for this bit here, is I'm looking at x plus 5 all squared. 30 divided by 6 being 5. So my starting bit is always to find what is this part, the x plus a all squared. It's going to be x plus 5 all squared. Expand it. X squared, 2 lots of 5 times x is 10x plus 5 squared, 25. Okay, now when I multiply that by 3 to get 3 lots of it, I get 3x squared plus 30x plus 75. And notice, I've got the 3x squared, I've got the 30x. If I'd only divided by 2 here and got 15, I wouldn't have got 30x, I'd have got 30x at this stage, and then when I multiply by 3, it would be 90x, it would be too many. So you divide by 6, get the x plus 5 all squared there, expand it, and then do 3 times it. And now we can say, well, 3x squared plus 30x plus 8 must be, well, 3x squared plus 30x is this take away 75, so it's going to be 3 brackets x plus 5 all squared take away 75, and then I've got plus 8, so it's add 8. So my answer is going to be 3 brackets x plus 5 all squared minus 67. So it's going to be quite tricky. So going through it, we spot that the k is 3. So you don't just divide through by the 2, you divide by 6 to get your 5. And notice I look first not at 3 times anything, I'm looking at the x plus 5 all squared, expand that. Then I find 3 lots of it, and I check, and I should get then 3x squared plus 30x, because it's 3x squared plus 30x there. Then I can just rearrange to get 3x squared plus 30x is 3 lots of x plus 5 squared minus the 75. If I want 8 more than that, I'll just add on 8. Right. The next type that's quite tricky is when you get a minus x squared involved. Notice things are now rearranged. 6x minus x squared plus 2 we write as b minus x plus a all squared. Right, let's have a look at this. Well, this can be quite tricky. So what I'd suggest you do is this. We let the y be equal to the 6x minus x squared plus 2. And then we find minus y. Now by doing that, we're going to turn it round so we get a plus x squared. It's easier to deal with. So we let y be 6x minus x squared plus 2, and then we find y minus y. Well, minus y, we change all the signs. It'll be minus 6x plus x squared minus 2 plus x squared minus 6x minus 2. So that's turned to a minus 6x, back to a plus x squared, back to a minus 2. Now it's easy to deal with. X squared minus 6x minus 2. So it's going to be an x minus 3 all squared, because I just cut that in half. So I get x minus 3 all squared. Obviously, here, if you remember, we then expand that, so you get x squared minus 6x squared plus 9. So you've got to take away the 9. We've also got that minus 2, so it's take away the 2. So you get x minus 3 all squared, take away 11. And that is what minus y is. So y, instead of it being this take away that, x minus 3 all squared take away the 11, It's going to be the other way round. It's going to be 11 take away the x minus 3 all squared. Okay. Now, let's see, do some questions. Solve by factorization. 5x squared minus 10x equals 40. The first thing here is we want things equaling 0. Whenever you're solving things, we want them equal 0. Okay, I've got a second question there. So the first one, that equals there, make it equal 0, bring the 40 across, so you get 5x squared minus 10x minus 40 is 0. Use the common factor. 5 comes outside, and you're left with x squared minus 2x minus 8. That's why I've got these numbers here, because I wanted the factors of 8, 1 times 8 or 2 times 4. Then I've got to factorize it in order to get it equal to 0. Now, because it's a minus 8, the signs will be different. Okay, and so I've got to try my numbers in here. I want 2x. Well, x and 8x can't come to 2x, but 2x and 4x can, so it's going to be a 2 and a 4. I want minus 2x. Now, if I do it that way round, that will give me plus 4x minus 2x. That's plus 2x, so it's got to be the other way round. It's going to be x minus 4, x plus 2. Let's check it. X squared plus 2x minus 4x is minus 2x, minus 4 times plus 2 minus 8 equals 0. Okay, now 5 isn't 0, so x minus 4 is 0, which is x is 4, or x plus 2 is 0, gives me x equals minus 2. So x is 4 or minus 2. Okay, right. What if there is no common factor? 6x squared plus 23x plus 10 equals 0. That's now getting really hard, okay? Now, often when people see factorizations, then you prefer to use things like the formula or something like that rather than factorization, but it is worth practicing factorization. So anything that factorizes, you want to be able to factorize it if you can, because often it's a lot easier than it seems if you just work through it systematically. So we've got 6x squared plus 23x plus 10 is 0. Well, the first thing, what goes in the front here? Well, we've got different choices. To get 6x squared, I could have 6x times x, or I could have 2x times 3x. Let's try 6x and x first. I want to multiply to get 10, so I've got 1 and 10, but they could be either way round. So I could have 1 there, 10 there. 60x, x can't come to 23x. The other way round, you can actually see it. You don't need to put the numbers in. You'll be able to see 6x, 10x can't come to 23x. So you can see straight away that that's not working. Try the 2 and the 5. Okay, see if that works. 30x and 2x can't come to 23x. No, so that's not going to work. Swap them around. Let's see what happens. 12x, 5x. Again, it's not working. So with the 2 and the 5 and 1 and 10, it didn't work with 6x and x. So let's try 2x and 3x. 2x, 3x. Okay. Try anything. I can do that. 10x and 6x. No. Okay. Again, you can actually drop these down. You can try the different things, or just do it in your head. 4x, 15x. Not working. So, let's hope these work. Let's try that. 20x, 3x. Good, we've got it working. And you see straight away, the other way around, 10 there would be 30x, 1 here would be 2x. That won't work. So here, we've got it working. It's 2x plus 1 times 3x plus 10. Check it through. 6x squared plus 20x plus 3x. That's 123x, and 1 times 10, 10. That is 0. Now that means, evidently I've written it when I did it before, I wrote 3x plus 10 and 2x plus 1 here. Doesn't matter how I write it down. 2x plus 1 is 0, or 3x plus 10 is 0. So that means that 3x is minus 10, so x is minus 10 thirds, or 2x is minus 1, so x is minus a half. You could have done another line of working there if you wanted, but 3x equals minus 10, therefore x is minus 10 over 3. 2x equals minus 1, so x is minus a half. Okay, completing the square. Solve this, it says, exactly by completing the square. So it's a tricky one because we've got 7x, and we always, when we do this, we're going to do, it's a single x squared, so we haven't got any problems with a number out here, but we still got to divide by 2. So the key thing here, use top-heavy fractions. Don't resort to decimals, okay? We'll deal with top-heavy fractions here. We certainly aren't going to use mixed numbers. So when you divide 7 by 2, you get 7 over 2. If we leave it like that, that's dead easy to square it. Now, so we've got x plus 7 over 2 all squared is what we're going to look at. Let's try expanding it. X is time x squared plus 2ax plus a squared. So you're going to get x squared plus 2 lots of 7 over 2x. Well, 2 lots of 7 over 2 is 7x. So that does come to x squared plus 7x. All we need to find is the last bit. Well, 7 over 2 times itself is 49 over 4. The square of each bit. So x squared plus 7x plus 3 is equal to x plus 7 over 2 all squared. That, take away the 49 over 4 and add on the 3. It looks quite tricky, but all you're having to do now is to say, well, 3 is 12 over 4. Put it as the same denominator. So we want 4 here, 3 is 12 over 4. So we've got minus 49 over 4 plus 12 over 4 is minus 37 over 4. So I put that as plus 12 over 4. 12 take away 49 is minus 37. Okay, so x plus 7 over 2 all squared minus 37 over 4 is 0. So we've completed the square. Now we need to solve the equation. Move the 37 over 4 to the other side and becomes plus. So x plus 7 over 2 all squared equals 37 over 4. Square root both sides. X plus 7 over 2, and don't forget the plus minus, is plus minus the square root of all of this. Well, we can't square root 37, but we can square root the 4, and so we could rewrite that instead as plus minus the square root of 37 over the square root of 4, which is 2. Now we just move the plus 7 over 2 across and get minus 7 over 2. And I'd write it as minus 7 over 2 plus minus the square root of 37 over 2. You could have put the plus minus 37 over 2 first and then put minus 7 over 2 after it if you prefer. Okay, now notice it said solve exactly. So we leave it like that. We don't press any buttons on calculators. You leave it like that as your answer. Those are the exact answers. So one answer is minus 7 over 2 plus root 37 over 2. The other answer is minus 7 over 2 minus root 37 over 2. Express 32 minus 12x minus 2x squared in the form p minus q lots of x minus r all squared. So it's saying complete the square for this. Now this one really is tricky. Not only have you got a minus involved with the x squared, but also it's not a single x squared, it's 2 lots of x squared. So it's really combining a couple of tricky methods. So you've got to be very careful. Well, because we see a minus in front of the x squared, we'll start by letting y equal that and find minus y. Okay, and then it says hence solve it, but we've got to do that bit first. So we let y equal 32 minus 12x minus 2x squared. Okay, we find minus y. So minus y, change all the signs. Minus 2x squared becomes plus 2x squared. Minus 12x becomes plus 12x. Plus 32 becomes minus 32. Now we've got to deal with this. Well, usually you just divide this by 2, but because there's another 2 there, we've got to divide by 4. Okay, so we're going to look at x plus 3 all squared. That's the key thing, is you've got to find what it is you're going to square here. So we look at it, you divide the 12x, always divide by 2, but also because there's a 2 outside here, we want to divide by 2 again. So we get x plus 3 all squared. Expand it. X squared plus 2 lots of 3x is 6x plus 3 squared, 9. Now, we want 2 lots of that to get 2x squared. So 2 brackets x plus 3 all squared becomes 2x squared plus 12x plus 18. And look back here, yes, 2x squared plus 12x, what we wanted. So we can now rearrange it and say 2x squared plus 12x minus 32 is equal to 2x plus 3 all squared minus the 18 minus the 32. So you're going to take that 18 away. And that simplifies to 2x plus 3 all squared minus 50. However, be careful, that there is minus 1. So minus y is 2x squared plus 12x minus 32. Minus y is 2 brackets x plus 3 all squared minus 50. So y is going to be the other way around. Instead of 2 lots of x plus 3 all squared take away 50, it'll be 50 take away 2 lots of x plus 3 all squared. Now we've got it in the right form. P is 50, Q is 2, R, instead of x minus R is going to be minus 3 because it's x plus 3 all squared. So that's what our y is. Hence solve 32 minus 12x minus 2x squared is 0. But it means that this has got to equal 0. This time I'll move the minus 2 lots of x plus 3 all squared to the right. So I get 50 equals, well, when it moves across it becomes plus 2 lots of x plus 3 all squared. Next stage, divide through by 2. And you get 25 equals the x plus 3 all squared. I'll move the x plus 4 squared to the left. Just easier to deal with. Equals 25. Now square root both sides, and I will get x plus 3 is plus or minus the square root of 25. The square root of 25 is 5. So x plus 3 is equal to plus or minus 5. So x is equal to 5 minus 3, which is 2, or is equal to minus 5 minus 3, which is minus 8. So x is 2 or minus 8. Okay, so I hope that helps you with your solving equations and completing the square.